This is Greg Stalker presenting information from a research article published in the 2000 European Journal of Applied Physiology, authored by G.J. Bell, entitled Effect of Concurrent Strength and Endurance Training on Skeletal Muscle Properties and Hormone Concentration in Humans. The purpose of this experiment was to study and compare the adaptations resulting from three different training programs: concurrent strength and endurance training, strength training alone, and endurance training alone. Since previous research on the subject yielded results of compromised strength gains when endurance was added to a strength program, the authors were inquisitive as to whether they could produce similar results and find out the reason why. Therefore, their hypothesis stated that an elevated catabolic state was to blame for the diminished strength gains following a concurrent strength and endurance training program. This study utilized 45 subjects, 27 males and 18 females. They were divided by sex and randomly assigned into one of four groups: strength training alone, endurance training alone, concurrent strength and endurance training, and a control group. All groups except the control group followed a 12-week training program. The strength group and the endurance group exercised 3 days per week, while the concurrent strength and endurance training group exercised 6 days per week. It's important to note that in the concurrent strength and endurance training group, only one mode of training was done per day, either strength training or endurance training. This was done in an effort to avoid overtraining. All groups received analysis prior to the start of their training program and at the conclusion of the 12 weeks. However, only the three training groups received another analysis after a 6-week period. Tests performed on the subjects included a skeletal muscle biopsy, blood and urine samples, VO2 max test, and 1 repetition max test. The strength training program was comprised of 8 exercises, 4 for the upper body and 4 for the lower body. All exercises were performed on machines and free weights. The lower body exercises included a double leg press, a double leg calf raise, and a single leg knee flexion and extension. The upper body exercises included a bench press, a shoulder press, seated pull downs, and bicep curls. All loads were based off the 1 rep max pre-test and were progressed 4% every 3 weeks. The endurance training program was performed on Monarch cycle ergometers and utilized 2 modes of training: continuous endurance training and interval training. The continuous training was done twice a week, starting with 30 minutes and progressed 4 minutes every 4 weeks up to 42 minutes. The interval training was done once a week and was comprised of 4 sets at a ratio of 1:1, with the progression of 1 set every 4 weeks up to 7 sets. All endurance training intensities were calculated and prescribed using the ventilation threshold of each individual subject's VO2 max pretest. The results of this experiment demonstrated once again that the greatest gains in strength were achieved by the group that did not incorporate endurance training into their training regimen. This experiment also demonstrated that the addition of strength training to endurance training program has no significant effect on VO2 max, evidenced by a similar increase in VO2 max by the endurance alone group and the concurrent strength and endurance training group. There are 2 pieces of evidence to support the superior strength gains made by the strength training alone group over the concurrent strength and endurance training group. One comes from the 1 repetition max post-test, and one comes from the muscle fiber evaluation. There were 2 1 repetition max tests taken, one for the leg press and one for the single leg knee extension. And while both groups scored similar results on the leg press, the strength training alone group scored significantly higher on the single leg knee extension. Further support came from the muscle biopsies, which showed hypertrophy of type 1 and type 2 fibers in the strength training alone group, unlike the concurrent strength and endurance training group, which only showed hypertrophy in type 2 fibers. At first, the researchers' hypothesis of an elevated catabolic state as the cause seemed correct. But when the blood and urine samples were evaluated, the explanation was not so clear. Of all the hormones and enzymes evaluated in this experiment, only female urinary cortisol was significantly elevated. Unfortunately, this was only a partial explanation and proof of the hypothesis. Indeed, much was left to be understood by the end of this experiment. Finally, I would like to add one criticism regarding the design, and it pertains to the training volumes assigned to the groups. I find it unfair to compare the data of a group that trains 6 days per week against a group that trains only 3 days per week. This appears to be an enormous design flaw and a possible explanation of the irregular results. This has been a presentation by Greg Stalker. Thanks for the view.